Alright, so let's talk about valency and ionic equations. Now, an ionic equation is when we make an ionic compound from two ions, or the reverse, and essentially, valency is how we predict what's going to happen with that. So what is valency? It's defined as the combining power of an element. And basically that means it's related to how many electrons are in the outer shell, or the valence shell. Let's have a quick look here. Now, you may have noticed this trend by now, or you may not have. Group 1 has 1 electron. Group 2 has 2 electrons. Group 3 has 3 electrons. 4 has 4 electrons. These are in the outer shells. 5 has 5 electrons. 6 has 6 electrons. 7 has 7 electrons. And 8 has 1. I'm just joking. 8 has 8 electrons. So you can see that's the group names. Now you've got these transition metals. They're all weird. Let's not worry about those for the moment. But these guys, that's what's going on there. So the valency of each one in a particular group is identical. The valency in group 8, because it has 8 electrons, is 0. And what that means is it needs not change. It doesn't need to change to make a stable outer shell. However, hydrogen and all of group 1 only have 1 electron in their outer shell. So they have a valency of +1. That means they have 1 electron to give. 1 electron to give away to combine. And that's really easy to do, and that's why these guys react really easily. In group 2, they have 2 electrons to give away. Okay, they give away 2 electrons, so they are +2. Because these guys, it's also pretty easy for them to react. Not quite as easy as these ones, but pretty easy. Come over here, and we get to boron. These guys have 3 electrons to give away, so they are +3. I'm going to skip carbon, and we'll go to group 7. Now these guys, they don't have any electrons to give away. In actual fact, for them to make a stable outer shell, because they have 7 electrons in their outer shell, they need to take 1 electrons. So how many electrons do they have to give away? -1. They have -1 electron because they need to take an electron from something else. 6 electrons means you have -2. You need to take on 2 electrons from somewhere else. 5, because you're trying to get to 8, means you have -3. You need to take 3 electrons on from somewhere else to get 8. 4 is a bit crazy. 4 can kind of go either way, because for 4, it's just as easy to gain 4 electrons as it is to lose 4 electrons. So it kind of depends on, when you're from carbon down to lead, what it is that you're joining it to. Alright, so one thing you'll notice here is metals have a positive valency. Non-metals have a negative valency. Remember, the line for metals is down that way? Sure, we'll go down that way. That's your metals. These guys are... Sorry, that's your non-metals. These guys are semi-metals. And the vast bulk of it is all metal. And these guys have your negative valencies. These guys have your positive valencies. Things get a bit weird down here, and that's not something you're ever going to have to worry about. Valency is basically determined by how many electrons an atom has to lose in order to achieve a stable electron. So sodium loses 1, so it has a valency of +1. Fluorine gains 1, which means it loses -1, so there's a valency of -1. Now, how can we use this to predict a reaction? Basically, if we write down, so we've got magnesium, so it's dissolved in water, so we've got ions acting together. So magnesium is 2+, and it is going to react with chlorine. So we've got magnesium and chlorine dissolved in solution. So what's going to happen? The best way to do this is the crossover method. Now, that minus, you could assume that that's -1. We don't ever draw that 1, but it is -1. So we'll get rid of it. So we do something called the crossover method, which means we take this 1 and put it there as a subscript. We take this 2 and we put it there as a subscript, which means we give MgCl2. And of course, that will still be aqueous in solution because that's not going to precipitate out. So basically, magnesium loses 2 electrons, chlorine gains 1. Now, because chlorine can only take 1 electron, we need 2 chlorines to take those 2 magnesium electrons for it to be stable. Alright, now I hope that made a lot of sense. If it didn't, feel free to ask questions in the comments below. We'll get back to you as quick as we can. We may update the video, whatever needs happening. And yeah, thanks for watching. We'll see you next time.